When you hear the words surface areas, what comes to in your mind? Yes, surface areas is area of surface, right? So it is not a just flat surface. So surface can come from the three-dimensional. So we're gonna have some three-dimensional and we're gonna calculate the surface areas of each of those shapes. So let's start with a cube. What is a cube? Cube has the faces, 6 faces, and all 6 faces have a shape of a square. Well, if you are looking at this box, for example, you can see that this is a square with 4 centimeter in each side. And same for this one. If you're thinking this is two-dimensional, it looks like parallelogram, not the square, but if you are standing here and looking at this box, it's gonna look just like this square. And for this one too, when you're looking down from up high, it's gonna look like square as well. So all 6 sides are square and we call that a cube. Sometimes it is not easy to just picture how it looks like and how to calculate the surface area. So a lot of times it helps to have a net. So net is when you are thinking about this as three-dimensional and cut it open. So if I cut that box open, it looks something like this, right? Especially this one, we see all of these squares have 4 centimeter as the side. Then we know how to calculate an area of this square. So this square is 4 by 4, which is 16 square centimeter. And same for this one, because this side is 4 centimeter, that's 4 centimeter, another 16, another. So we know that there are 6 exactly identical squares, and each square has 16 square centimeter as the area. So we have 4 squared, and you have units there as the surface area of a cube, right? If you are given any length, for example, A, whatever the unit is, and this is also A, because in the cube, every side, every face is a square. A square has all the equal side. So we know that the area of one square will be A squared, and there will be 6 of them. So you can say that surface area of a cube can be 6 times a side. A is a side length, A squared, and you can put the unit square there. So you can come to a conclusion, right, of the formula. So instead of just remembering the formulas, it's better to understand why you are getting that formula, right? Okay, so we can come to this conclusion. If the side of a cube is S, then surface area of a cube will be 6 times S times S, the area of each square, right? So that's very simple. And let's think about lateral surface area and surface area of a prism. So what is a prism? Let's review prism a little bit. Okay, so prism, if you are having triangular prism, your top and bottom, we call them base, are exactly the same size and same shape. So they are identical. And each of those sides, the faces around them, we call that lateral surface, and they are rectangular shape because these are 90-degree angles, right? So if you open that up, you're gonna have 2 triangles, top and bottom, they are bases. So base 1 and base 2, right? Exactly same size. And if you open this up, you're gonna have 3 of those. rectangles, exactly the same, right? I'm going to show you how you can use some virtual manipulatives for that. Again, this is in GeoGebra. This is called a triangular prism because, as you can see, two bases are congruent, exactly the same size and same shape. And I'm going to show you how to unfold the bases. Okay, so I'm going to unfold these two bases. Then they look like triangles, especially equilateral triangles, where all three sides are congruent. And I can unfold the lateral bases slowly like that. So you can see all of these bases are meeting at the edge of the base's edges, right? So this rectangle meets with this one. So can you imagine that? If I unfold them, it looks exactly like that, right? And goes down there. So you can see that, right? And I can change that to rectangular prism. So you can see we have two bases again, and each of these lateral faces are still rectangle, right? But bases are the squares. I'm going to show you 5 sides. 5 sides, you have 5 sides of the pentagon on the bases, and you have 5 rectangular lateral faces. So if you close them, it looks like that, right? So pretty obvious. If you have hexagonal prism, you're gonna have 2 bases with hexagons, and if you unfold them, you're gonna have 6 lateral faces, 6 rectangular lateral faces. So you got the idea, right? Then how do we find the prism's area? We can do 2 times of the base area, no matter what the shape is, right? If it's a hexagonal, we have learned how to find the area of a hexagon using the triangle. If it's a pentagon, you can find area of a pentagon, making 5 triangles, right? And you're gonna double them, and you can find the area of one rectangle, and you can multiply that by 5 for pentagonal prism. If you have triangular prism, of course, you can find triangle's area times 2, and you can find the area of a rectangle times 3, right? So we have some idea here. We have some sense of the prism and its surface area, right? So for the prism, we know that 2 bases are congruent. So 2 times 1 base can be added as the surface area. Now we need to think about the lateral surface. So lateral surface, we know that it is a rectangle. In our example, we're using the nets. We have regular bases in which all the 5 sides are congruent, but it doesn't have to be all the same size, right, for the prism. So let's suppose S1, S2, S3, S4, S5. It doesn't matter whether they are all congruent or not. So we know that if you open them up, you're gonna have S1, S2, S3, S4, and S5. The length again does not matter, but we know that there will be rectangular shapes for the lateral surface all around, right? And it can be one whole piece of rectangular shape, in which we know that height is h. And how about the length of this rectangle? You can just add up all of these length around it, right? So we know that it will be S1 plus S2 plus S3 plus S4 plus S5 if you have 5 sides, right? So we can say that this is perimeter of the base, and we can put that as P, just perimeter of the base, times height. Perimeter of the base times height will give you the lateral surface area. So lateral surface area plus top and bottom 2 bases will give you the surface area, right? So it makes sense. You don't have to remember that, just understand what's going on. So for example, if you are given a triangular prism here, this is right triangular prism because the triangle on the bases are right angles, right? So these triangles are not regular triangle. They are not equilateral, but still we can find the bases, right? So base area is one right triangle in which I see one side is 5 inch, the other side is 6 inch, and hypotenuse is 7 inch. How do we find the area of the base? Base times the height and divided by 2. So 1/2 times 5 times 6, which is 15 square inches. That's one base area. So this triangle is 15 square inches. Then the other triangle space is 15 square inches of area, right? Now we can take a look at lateral surface. If you open them up using the net, you're gonna have a rectangle like that, and you're gonna have a right triangle, right? You're gonna have a right triangle. So I can have, this is 7, and this is 5, this is 6. So this will be 5 and this will be 6 inches. So we know that in this rectangle, the width is 7 plus 5 plus 6, right? 7 plus 5 plus 6 is the width, and the height is the same as the prism's height, which is 12. So if you multiply the length here, the base 7 plus 5 plus 6 times the height 12, you're gonna find the area of this rectangle, right? So how do we get that? 7 plus 5 plus 6 is, what is it? 13, 18. 18 times 12. What is 18 times 12? I'm gonna get my calculator. 18 times 12 is equal to 216 square inches. So we have area of 216 square inches and 15 square inches together with these triangles. So the area of this triangular prism should be 15 plus 216 square inches, or that is same as 231 square inches. Okay. I strongly suggest you to resolve all the problems, okay? And now let's talk about surface area of a cylinder. What is a cylinder? Cylinder is very similar to prism. So prism, we had polygons instead of a circle, right? And we knew that two bases are exactly same sizes, congruent. And same for cylinder, we just change, those bases from polygon to circle. So then it becomes a cylinder. So two bases are congruent, right? Two bases are congruent, and you have rectangular shape as the lateral face. Then it is a cylinder. So if you cut that cylinder open, it looks like this. How do you find the area of this surface? Well, we have two congruent circles, and we know how to find the area of a circle. This is pi r squared, in which r is the radius of that circle. Same here, pi r squared, right? How about this rectangle? Think about the height. It's exactly the height and same height here in the cylinder. But how about the width here? The width is, thinking about, the circle, rolling it up from here to all the way down there will be the length here, which is the circumference of a circle. How do you find the circumference of a circle? 2 pi r. So the width is 2 pi r, and the height is h, and it is a rectangle. So the area should be width times height, 2 pi r h. We can just add them up, right? Pi r squared, and we have two of them, so 2 pi r squared, and the rectangle here is 2 pi r h, right? So you can easily find the formula Even if you don't know the formula, just cut out cylinder and solve the problem. For example, if you are given a cylinder with radius of 3 centimeter and height of 10 centimeter, what is the surface area of this cylinder? Think about it. We have two bases, and each base has radius of 3 centimeter. So the area of this should be 3 times 3 pi. Pi r squared. Pi times 3 squared, which is 9 pi. And you have two of them, right? And you can think about opening this up, having a long rectangle with a height of 10 centimeter. And the length here, the width is the length around the circle, which is the circumference of that circle, of this circle. So 2 pi r, 2 times pi times 3, 2 pi r, which is 6 pi centimeter. So the rectangle's area here should be 6 pi times 10, which is 60 pi. So surface area, you have 2 times 9, 18 pi, and you have 60 pi, and everything is in square centimeter because it's an area. So if you are adding them together, 18 pi and 60 pi, it's 78 pi square centimeter. Okay. Now let's think about pyramid. What is a pyramid? Pyramid has a base, and there's one point outside of the base, and all of those lateral faces meet with that point. We call this as apex. This point is called apex. Okay, so there is an apex and there are vertices, or 4 vertices. So there are 5 vertices in the pyramid in this specific case. So apex is always one point in the pyramid that is not on the base. So in this case, we have square pyramid, but it doesn't always have to be square pyramid, right? It can be hexagonal pyramid too. So then you're gonna have 6 sides as the base, and apex is outside. You can connect all the vertices of the base with that apex, and then you can make a pyramid. This one is hexagonal pyramid. My drawing is not perfect, but you got the idea, right? How do we find the pyramid's surface area? Think about opening this up. If you open this up, you're gonna have a square in the middle for this specific case, and open up, and all the lateral faces are this time triangle, right? They are triangle, especially this and that are congruent. But anyways, we have triangles, right? So how do we find the area of this, this surface area of the pyramid? So if you are opening that up, you can find the area of the space. Whether it is a square or a hexagon or a different shape, you can find the area of the base. So I'm gonna put that as the area of a base with B. Okay, and if you open this up, all of the lateral faces are triangular shape like this. How do you find the triangle's area? We need to know the length here. We can get to know, right? It's B in this case. So B times height, which is the length on the slant here. So L and half of that. And especially these 4 are exactly the same sizes, right? So we can do 4 times triangular surfaces area, right? So as you can see, surface area of a surface area of a right regular pyramid, you can have base plus these are exactly same size, so n many times 3 or 4 or 5 or 6, triangular shapes area. So 1/2 of n times length. Well, this is b, right? B times length. So you can come to this idea. So I'm gonna give you another example here. It's a hexagonal pyramid. Especially this is regular hexagonal pyramid, so you have all the same length of the hexagon here. Let's suppose each of the side in this hexagon is 3 inches, and the length here with a 90-degree angle is 7 centimeter. Then what is the surface area of this regular right hexagonal pyramid? We know that hexagonal shape has exactly same triangle, 6 of them, right? And we know that this is 3 inches, and you also need to be given that A, so the length from this one corner to there, from in the middle, from there to the center, should be given to you. Let's suppose that is 4 inches. Everything is inches, sorry. So this is 4 inches. Then how do we find this area of one tiny triangle? It's 1/2 times 3 times 4, right? And that is 6 square inches. Each of these triangle has 6 inches of square of area, and I have 6 of them. So the base will be 6 times 6 square inches. That gives me 36 square inches. Now I need to find out the area of one triangle and multiply that by 6, because there are 6 of them, right? So now I'm looking at the lateral surface of one triangle first, and then multiply them by 6, right? And in this one triangle, so let me use different color for you to see better. This one lateral surface, I know that the base is 3 inches, so this is 3 inches, and the height here is given to you as 7 inches. So that is 7 inches. Because we are given base and height, we can find the triangle's area, right? That is 1/2 times 3 times 7. And we have 6 of them. So we will have 3 times 3, 9 times 7, 63 square inches. So lateral surface has 63 square inches, and the base is 36 square inches. The big difference between this and the prism, you have only one base, right? So you can add them together. So base plus lateral surface is equal to the surface area. So base, I got 36 square inches, and I have 63 as lateral surface. And the total, I have 99 square inches for this hexagonal pyramid, right? Okay, so here are some more examples, and you can solve that. Shall we do that together? Okay, so if you think about this, I have one base, which is a square in this case, right? Because it is shown as 90-degree angle. So the square has 6 centimeter and 6 centimeter. So the base of this bottom will be 36 square inches, right? And I need to look at the lateral surface. If we are looking at lateral surface, you are given, take a look at this triangle here. Oops. Take a look at the triangle here. You see, the base is 6 centimeter and the height is 4 centimeter because it's 90-degree angle here. So I know 1/2 times 6 times 4 will give you one face, right? But we have 1, 2, 3, 4 all same thing, so there are 4 of them. That is lateral surface. And if you're simplifying this, you have 12 times 4, which is 48 square centimeters as surface area, lateral surface area. So together, surface area is base plus lateral surface, and our unit is square centimeter. So that gives me 84 square centimeter. Now let's look at cone. What is a cone? Cone is similar to the prism, not prism, sorry, pyramid, right? Because you have only one point outside of the base, very similar to the pyramid, right? Okay. How do you find it? It's a little bit more complicating, so I'm going to use still the net. So if I open that up, it looks like this, right? So I see L as a slanted height, and I have R for the radius of the base circle. Now we know how to find area of the base. That's so simple. It's pi r squared. Okay, so base is pi r squared. How about the lateral surface? That looks like a sector of a bigger circle, isn't it? So we need to think about how you're gonna find that. Okay, have you thought about that? So here is a bigger circle. Accidentally I erased it. So you can see that this is a sector of a bigger circle with a radius of r. And the area of this base of a cone is pi r squared because the radius of this small circle is r. Right? We got that. Now we need to think about the lateral surface. Lateral surface is part of a bigger circle. So we need to see how much part is it taking from the bigger circle. We know the bigger circle, the length around the bigger circle can be found as a 2 pi radius, and the radius is L. So this is 2 pi L. So I'm thinking about the circumference as 2 pi L. 2 pi L. This is 2. Come on. 2 pi L. Right? And think about, the length around here. That's what, because I'm looking at the length here compared to the bigger circle. Because for the area, we can easily find pi r squared or pi l squared in this case as the area, and we need to find how much it's taking by comparing the same ratio of the length of this part out of the total. Okay, so let me say that again. We want to find out how much it's taking from the bigger circle's area, because the ratio of this area to the bigger circle should be same as the ratio between the length here to the bigger circle, right? So because we cannot find the area directly, we're gonna see if we can find any ratio between this length and around the whole circle length. We can find the big circle's length is 2 pi r, which is the circumference of this circle with the radius of L. So 2 pi L, right? And compare that to this is a circle, and I'm looking at the sector. Compare that length to this part, so whole 2 part. This length, apparently it is the length around this circle, right? Because if you put this circle here and you roll it, then from this end all the way around, that comes down there. So we know that the length of this sector, so we call that arc length, that arc length is exactly same as the circumference of this smaller circle, which is 2 pi r. So the relationship between the big circle and the smaller sector, so whole and part, is 2 pi l to 2 pi r. If we simplify that, both are divisible by 2 pi, so you have left L to R ratio. So the length around this, the size of this and the size of that sector has L to R ratio. L to R ratio, right? Then think about the area of this sector. Compare that to a bigger circle. So if you are finding the big circle's area with L with a radius, pi L squared is the area of a big circle. But we are taking only the part of it, right? So if you are thinking about pi L squared as the area of this big circle, we're not taking all of that, but we are taking only part of it. And that is only R over L, part over whole. This is the constant ratio between bigger circle and the sector. So you can find the ratio between bigger circle's area and smaller sector's area with this ratio, right? So we know that it's taking only fraction of this big circle. That fraction is R over L. So if we simplify that, this will be gone, and pi RL or LR is your sector area. So lateral sector area, lateral surface area is pi RL or pi LR, right? Then surface area of a cone is equal to base pi r squared plus lateral surface, which is the sector, pi r l. Okay, so that is the formula for the surface area of a cone. Now, knowing that, we can solve some problems here, right? Oh, do I have example without answer down here? No, I don't. Okay, so let's look at that. So the base, I already have you the answer here, but by just let me cover that up actually, and let's solve that together. How about that? Okay, so pause the video again and solve this surface area of this specific cone. Okay, and then check that out with me. So the base is a circle, pi r is 5 centimeter squared, which is 25 pi square centimeter. Now we have lateral surface here, which look like a sector with 12 centimeter as the big radius. And we know that around this, that is 2 pi r, which is 2 times 5 times pi, 10 pi, right? 10 pi as the arc length. But we know that the surface area of this lateral surface will be pi RL. So pi times R is 5 and L is 12 centimeter. So that gives us 60 centimeter, square centimeter, right? And together, base and lateral surface together, that will be 85 pi, oops, I forgot to put pi there, square centimeter. That we are going to see is a sphere. Sphere is very similar to circle. The difference is circle is 2-dimensional and sphere is 3-dimensional. The definition is very similar. So circle, if you remember, there is a center and equidistant points, collection of all the equidistant points are called circle, right? Similarly, from the center, if you have equidistant points in all around three-dimensional, then it becomes a sphere. So from the center, for any surface of a sphere, it has equal distance, right? So that is a sphere. And sphere, it is hard to prove how to find and show the surface area. So I will just ask you to remember the rule. So surface area of a circle is 4 times pi r squared. Pi r squared is the circle, but it's like 4 times of that. Okay, so very simple. And let's apply this to find the surface area of this sphere. So when you're looking at this sphere is not giving you a radius, but it's giving you a diameter. Diameter is 10 centimeter. Then what is radius? Radius is half of it, because all the distance on the surface of a sphere is equidistant from the center. So this is just 5 inches, because this is also 5 inches, right? So here our R is 5 inches. Then surface area will be 4 times the circle, pi times 5 square, and inch square is the unit. So that gives us, excuse me, 5 times 25, 100 pi square centimeters. That's it.